Open the Projects tab, right click, New Project, not New Folder, name of the project, right click, New Schematic, that's what we're starting off with. Schematic is the blueprint. Open up our window here, and that's basically where we would start from. It's a clean canvas. Okay, let's go over the Eagle GUI. Left hand side, icons, you all know what they are. Down to the bottom left tells you what they are. Just go over them individually on your own, see what they are. On the right hand side, obviously this is default layout. Text labels, smaller subset of what's available on the left, but the basic parts, basic shortcuts that you're going to use. You can use either or, it doesn't matter, they're exactly the same. You can also use the text interface, type stuff in up here, type stuff that makes sense though. I prefer the console myself. It gives me a little bit more working space and I'm just used to it. Obviously on the top, just the regular menu where they are repeated again and shortcut keys. So that is the basic GUI. Okay, let's look at some basic Eagle stuff. One of the most important things about Eagle, and it tends to catch people at things, is the grid. So let's take a look at the grid. Either click up here in the top left on the default, type grid, or GRI, and what we see here is basically the default Eagle grids. Probably put the default just to make sure. So it's in inches. It's typically best to stick to inches, even though most of the country uses metric. But board houses tend to use inches, and if you use millimeters, you'll get giant boards back or really tiny ones, and everybody gets really confused, so we all tend to stick to inches. This is fine for the schematic, we'll leave it here. We'll look more closely at the grid a bit later when we get to the board, where it's much more important. Display, turns it on, turns it off, very simple. Okay, so that's the grid. The next thing we want to do is actually start drawing with primitives. So let's look at the wire command. The wire command is used either to draw symbolic wires or actual wires. So we could get over here or over here. As you can see, left click to start wire. This is the PC version. We want to use 91, which is the netless layer. I'll go into that later again in a bit more advanced class. Don't worry about it right now. And these are the types of wires we're drawing. Eagle will automatically try to route the wire as best it can. Mitre basically makes them circular at the edges. Width is the width wire in inches. Continuous, long, short dash, that's for the symbolic stuff, so if you want to draw dotted lines and so on. So basically pick where you want the wire to go to, left click, down, draw it, that's the wire. It will keep doing that until you cancel it. If I hit the escape button, that does it. So same thing again, left click, and if we move around you can see the way that the wire type is going with the highlighted one at the top right here. So that's how that one's highlighted, so it's kind of drawing that shape. If you click the right mouse button, it will move to different types. This is the freeform one. Here we go, another type, another type, another type, and so on and so forth. I tend to stick to this one, but we do change it. So there we go, a wire. Press escape to cancel drawing. Okay, so let's start creating the schematic. Over here are the sheets. We're only going to use one sheet on this particular circuit because it's very simple, but you can add new ones, and basically it's two blank pieces of paper. Let's remove them for the time being. Go over here. So the first thing we want to do is use the NSL library that I've pre-created for this class. So we go to library, to use, select the library, browse to it, open it. And now Eagle now knows about the components that are inside that library. So then when we click add, it will bring up the list of all the libraries that Eagle knows about. Some of these come with Eagle, some of them have been created, downloaded from the internet. So a note about libraries downloaded from the internet. A lot of people create parts, they just kind of have fun doing it and upload, but they never actually verify them. The SparkFun library that tends to be out there, people use that one a lot. That has a lot of verified parts, but it also has a lot of unverified parts, and some of the parts are just plain wrong. But they do warn you about this, but regardless, people make them anyway. So that's why I like to either create my own parts or verify them before sending them off. So let's scroll down, let's click type N, and there is the NSL library. I want to open it up. These are the parts that we will be using for this particular schematic. We're going to start with the ATtiny. There's the symbol for it, and we want the MLF20 version of it. So this is the small micro lead frame, or QFP package. And we're going to use it. So basically click on it here, it'll be here, and then click OK, and here it is. So pick a place where you want to drop it down to, click, and there it is. That's as simple as it is. This works the same way for every thing we add in Eagle. So the next step is to basically use the rest of the schematic. So let's have a quick peek at it again. It's a very similar part. This has a slightly different layout, so we have to watch for that when we reverse the schematic. And we look at the wires and the different parts to where they go. Back to Eagle. Alright, so let's look at the schematic we're going to make. And if you're living in a tree, it's this guy, which is this. Evil Mad Science, Doctor Who, it goes back and forth, Cylon, we all know what it is. If you don't, get out. And what we're going to take is make this and make it smaller. So here's the schematic for it. We're going to make our own. It uses the ATtiny 2313 Atmel chip, which is very, very small for the version we're using. They use the DipPic package, which has the pins that you're probably used to seeing. A couple of resistors, a few LEDs, decoupling cap, switch, and a program header, and then the USB port. Probably going to only put some of these on because you don't really need the TX RX lines, and we need the optional to be able to chain them together. So the first thing we have to do is convert this into Eagle. Okay, so we added the AVR. Well, let's add some more parts. Click add. Okay, we don't need the processor anymore because it's already there. This is the pin header for the JTAG. It's actually the in-circuit programmer. So let's throw that down there. We're just going to throw the components on here one at a time as we need them. The switch. That, and pop it down. Now you can zoom in and zoom out with the wheel mouse if you have one. If you can't, you can't. So, okay, let's add some more parts. We need the battery. We're going to use the 20mm PTH. So that's the one that we have for the thing. Drop that down. We're just kind of randomly placing the parts around at the moment, no particular order. Capacitor. Obviously, I'm doing this all from memory. So obviously, these different size of capacitors: 402, 603, 805. 402s are very small, 603s are pretty small. So let's go with pretty small. Click OK, and we're going to drop that one down. That one's C1. Okay, and again add. And let's add the jumpers. So at the edge of the board, there's going to be two jumpers, an input and an output. So let's take those. We will take these two here. So these are through the whole components. Now, one thing Sparkfun does is kind of interesting. They have the lock. So this would be the normal one with correct spin spacing. What they do is you can look at the top here, they'll change. And you basically just move it out ever so slightly, and that helps them when they're creating their products by hand. So it offsets the spacing a little bit, and so when you put through the whole component in there, it'll stay in there because it's being held, in the holes, whereas this one normally wouldn't, and it'd fall out. So they use that as part of their manufacturing process. It's kind of neat, but it also means that you can't do spacing the same, and I use the middle of these components to run wires through sometimes, so I'm going to stick with the regular one I have. And let's drop those down. So we have two of those, one for each side. Okay, let's next add some resistors. So they're going to be a resistor for each of the LEDs. Again, these are the sizes. We're going to go with the 603s. Again, you can change these later, so it doesn't really matter. Let's pop them down. Now, what I did here is I'm pressing the right mouse button, and that's allowing me to rotate the part. So let's start by dropping these down again, picking a random kind of location at the moment. I'll show you how to move things around. And drop them down like this. And we'll keep things in kind of the order that the original schematic was. Evil numbers from 0, but they are actually numbered from 0 through 8 in the original schematic, so we'll keep that. And I'll come back later and name R9 to R0. Okay, next is the actual LEDs themselves. We're going to go with the bigger ones that we can get, which are the 1206s, and drop them down. Obviously, again, look at the schematic. We're going to line these up. Oops, didn't mean to do that. Control Z gets rid of it. Could have moved it, but I didn't. Again, line up, pop it down. And again, keep doing that until add it back over here. Add number 9, which again is going to become 0. I'm going to rename them anyway. Okay, so we've added, I'm going to hit Alt F2 here on the PC. That's going to do a zoom to fit all of the parts that are currently on layout. So are almost there, including, so let's use another one of the commands called move, which basically allows us to pick up parts and can move them around a little bit, make things a little bit neater. I usually like to add most of the components first before adding any of the wires. So the next thing we're going to have to add is power and ground. So let's look for that. I'm going to use the VCC supply symbol, which is basically just a schematic. I'm going to add the battery side, one for the decoupling capacitor, and then that's it for the VCCs. Okay, next we're going to add some grounds, and these basically just tell Eagle what we're connecting to the ground, and later on to actually draw onto the board. We have a few different grounds here. Pop them here, and another battery, one coupling capacitor.